Welcome dear students. Today we are going to discuss from class 9 mathematics book chapter 8 Quadrilaterals part 2. Dear students, in earlier session we discussed something about quadrilaterals. What are they? Angle sum property of quadrilateral means the sum of the interior angles of a quadrilateral is 360 degree. And we also discussed about some definitions of certain type of quadrilaterals such as trapezium, parallelogram, rectangle, rhombus and square. What is parallelogram? If the opposite sides of a quadrilateral are parallel, then they are called quadrilaterals are called parallelogram. If one pair of opposite sides is parallel, then the quadrilateral is called trapezium. And what is rectangle? In a parallelogram, if one angle is 90 degree, then that quadrilateral is called a rectangle. So what is rhombus? In a parallelogram, if all the sides are equal, then the quadrilateral is called a rhombus. And square, all sides are equal and all angles are equal, means each angle is 90 degree. Such type of quadrilateral is called square. Then we have to note that what is distinguished between these two and what is similarity, what are the dissimilarities between them. Note that a square, rectangle and rhombus are all parallelograms. A square is a rectangle and also a rhombus. But a rectangle or a rhombus is not a square. All rectangles are not square, all rhombus are not square, but all squares are rectangle and as well as rhombus. Now see, a parallelogram is a trapezium, because what is trapezium? One pair is parallel. In parallelogram, we satisfy this condition. So, a parallelogram is a trapezium, but a trapezium is not a parallelogram, as only one pair of opposite sides is parallel in a trapezium, and we require both pairs to be parallel in parallelogram. So, a trapezium is not a parallelogram. Now, today we are going to discuss about some more properties of quadrilateral. That is one is based on diagonal and the other based on opposite sides. Let us start one of these property by a theorem. Theorem 8.1, that is, a diagonal of a parallelogram divides it into two congruent triangles. Whenever we draw a diagonal of a parallelogram, we can see two triangles. Here ABCD is a parallelogram and AC is one of its diagonal. So we get here two triangles, that is ABC and triangle ADC. So here it is given that in ABCD is a parallelogram and AC is one of its diagonal. What to prove? Here we have to prove that the triangles so formed are congruent, means triangle ABC is congruent to triangle CDA. So how to prove it? Let us see. Here BC is parallel to AD and AC is the transversal. So we have two alternate interior angles, that is BCA and DAC. These two are interior alternate angles or pair of alternate interior angles, so they are equal. Also we have AB is parallel to CD and AC is transversal, so angle BAC is equal to angle ACB. This is also due to pair of alternate interior angles. Also, AB is parallel to CD and AC is transversal. So, angle BAC and ACD are interior alternate angles or alternate interior angles. So, these two are also equal. Now, you see we have to prove the congruency. So, let us take the triangles ABC and ADC. In these two triangles, we have angle BCA equal to DAC and angle BAC is equal to angle ACD, and AC is common to both of them. So, these two triangles are congruent by ASA, means angle side angle congruency. So, we proved the theorem as it is required. As these two triangles are congruent, we can have some congruent corresponding parts of the congruent triangles to be equal. So, if we consider the things, let us see. In triangle ABC and triangle CDA, as they are congruent, we have side AB and side CD to be equal, and side AD is equal to side BC. So, these are the corresponding parts of congruent triangles. So, they are equal. Now, from this statement, we conclude something. What do we conclude? The parallelogram is a quadrilateral in which opposite pairs are also equal. So, this can be stated in a theorem like this. In a parallelogram, opposite sides are equal. If this is the statement, what is the converse of this statement? Converse means what is given in the theorem. In converse, we have to prove that, and what is proved in the theorem, we have to, that is the given in the converse of it. So, here it is given parallelogram and proof was two sides are equal. But here in converse, the sides will be equal given, and we will prove that the quadrilateral is a parallelogram. So, that states like this: if each pair of opposite sides of a quadrilateral is equal, then it is a parallelogram. Let us see how to prove it. So, for that we have to draw a figure. A figure is like this: ABCD is a quadrilateral. So, we can write that ABCD is a quadrilateral in which AB is equal to CD and AD is equal to BC. And what to prove? We have to prove that ABCD is a parallelogram. Now, as in previous case, we need construction. Here also we need a construction. Why? To prove it to be parallel, we need a transversal of AB, CD and BC, AD. So, let us draw the diagonal AC. So, draw the diagonal AC. Now, how to prove? In triangle ABC and triangle ADC, what are equal? The opposite sides, that is side AB and CD are equal, and AD and BC are equal. So, we can write AB is equal to CD as it is given, and AD is equal to BC, it is also given, and this AC is the common line or common side. Now, here three sides, corresponding sides of two triangles are equal. So, triangle ABC is congruent to triangle CDA by side congruency or SSS congruency. Now, you see, as these two are congruent, so their corresponding parts must be equal. So, we can write that BAC equal to BAC is equal to ACD and BCA is equal to a DAC. BCA is equal to DAC. Now, these are the corresponding parts of congruent triangles. So, they are equal. Now, transversal AC intersects AB and CD and alternate interior angles so produced are BAC, which is equal to ACD. As the alternate interior angles are equal, so AB is parallel to CD. Similarly, if the transversal AC intersects AD and BC and alternate interior angles so produced are BCA and DAC, then BC is parallel to AD. So, in this quadrilateral, opposite sides AB and CD are parallel, also AD and BC are parallel. So, we can say that ABCD is a parallelogram. Dear students, today as we learned about the opposite sides are parallel and equal, from basing on this we will solve some problems. Let us see the problem. ABC is an isosceles triangle in which AB is equal to AC. AD bisects exterior angle PAC and CD is parallel to AB. Show that ABCD is a parallelogram. Let us see. See, this is triangle ABC in which AB is equal to AC and BA is produced towards P and PAC is the exterior angle. AD, this is the bisector of angle PAC and CD is parallel to BA. So, this point is D. So, here we can say what is given in triangle ABC, AB is equal to AC, exterior angle PAC is bisected by AD and CD is parallel to AB. This is given. To prove that ABCD is a parallelogram. Now, how to prove it? Let us see. As in triangle ABC, AB is equal to AC. This implies angle ABC is equal to angle ACB. Now, the exterior angle of triangle, that is PAC, angle PAC is equal to sum of the interior opposite angles ABC and ACB. Now, we know these two are equal, so we can say this is equal to 2 ACB. This implies 1 by 2 PSE is equal to ACB. What is 1 by 2 PSE? AD is the bisector PSE of angle PSE. So, half PSE equal to DAC. So, in place of half PSE, we can write DAC is equal to ACB. Now, you see AC is the transversal of AD and BC, and alternate interior angles which are alternate interior angles, DAC is equal to angle ACB. So, this implies AD is parallel to BC. We have also given that AB is parallel to CD. Now, in the quadrilateral ABCD, AD is parallel to BC and AB is parallel to CD. So, this implies ABCD is a parallelogram. So, by using the property that the opposite sides are parallel, that of a parallelogram, we proved it that ABCD is a parallelogram. Let us see another problem. Here in this figure, ABCD is a parallelogram. 2 points P and Q are taken on diagonal BD such that DP is equal to BQ. Show that APCQ is a parallelogram. Now you see here ABCD is a parallelogram and BD is the diagonal. We have point P and Q in such a way that DP is equal to BQ. Now, we have to join AP, PC, QC and AQ. We have to show that APQC is a parallelogram. So, here it is as given in parallelogram ABCD, BD is diagonal and P and Q are points on BD such that DP is equal to BQ. Now, what to prove? We have to show that APCQ is a parallelogram. You see, in triangle ABQ and PDC, we have angles like PDC and ABQ are alternate interior angles as AB and CD are parallel and BD is the transversal. Again, AB is equal to CD as the opposite sides of a parallelogram, and also BQ is DP. So we can prove this to be congruent triangles. So we can write BD is transversal of AB and CD, AB parallel CD we may write. This implies angle ABD is equal to angle BDC alternate interior angle. Now you see, in triangle ABQ and triangle DPC, we have AB is equal to CD. Why? Because they are opposite side of parallelogram. Now you see, and angle ABQ is equal to angle PDC, as here it is proved. Again, we have DP is equal to BQ. Better we write BQ equal to DP. So by these three conditions, we proved that triangle ABQ is congruent to triangle CDP. As these two triangles are congruent, this implies that AQ is equal to PC by corresponding parts of congruent triangles is equal. So AQ is equal to PC. Now, in similar manner, we can prove that AD, the transversal is BD, so BD is transversal of AD parallel BC. So angle ADB is equal to angle DBC. Now in triangle ADP and triangle CBQ, we have AD is equal to BC, that is again opposite side of the parallelogram. Then DP is equal to BQ as it is given, and the angle ADP is equal to angle QBC. So this implies these three conditions states that triangle ADP is congruent to triangle CBQ, which again gives that FP is equal to QC. Now you see, in quadrilateral APCQ, we have AQ equal to PC, and also we have AP equal to QC. As the opposite sides of the quadrilateral are equal, so we can say that APQC is a parallelogram. Let's number it 1 and number this as 2. So we can write here from 1 and 2 we can say APCQ is a parallelogram. You see, here we used the property that if the opposite sides of a quadrilateral are equal, then the quadrilateral is a parallelogram. So to prove this, we used the congruency theorem of triangle. By proving the congruency, we proved that the opposite sides of quadrilateral APCQ are equal, so that the quadrilateral APCQ is a parallelogram. Dear students, today we discussed about the diagonal property, one of the diagonal property, that is diagonal divides the parallelogram in two congruent triangles, and also we discussed about the opposite sides property, that is the opposite sides of parallelogram are equal. So dear students, this is time now. Thank you.